Next, we're going to move over to the next chapter, 6.9. And if one variable is equal to another variable times some constant, then that variable is said to vary directly as the other. So for example, y equals kx means that y varies directly as x. So you got one variable is equal to a constant times another variable, then y is said to vary directly as x. Let's look at the terminologies on the bottom of page 352. Right at the very, very bottom under the blue box, or the purple box. It says, in direct variation, as one variable increases, the other variable increases as well. The terminologies that we might use might say y varies as x, y is directly proportional to x, or simply y is proportional to x. If we know the values of two of the three numbers in this expression, then we can always find the third. So for example, if x was equal to 25 and y was equal to 7, then y equals kx is the same thing as 7 equals k times 25, or k is equal to 7 over 25. If you divide both sides of that equation by 25, this is what you get. So in that case, the equation would have been y equals 7/25 x, like so. Now recall that this is a simple version of that slope-intercept equation that we talked about before. You remember the general form of the slope-intercept equation is y equals mx plus b, where that was the intercept and that was the slope. So in this case, there's no intercept part out here, but that's a simplified version of that slope-intercept equation, and the constant in front of the x is the slope. So the slope in this case for this equation would have been 7/25. Let's look on page 554 at example number 3. So we're going to read through this one. It's a kind of a complicated one, right? It says, carat ratings of gold objects. Through 21st century technology, the 2009 ultra-high relief double eagle 24-karat gold coin was issued. It fulfilled Augustus St. Gaudens's vision of a high-relief coin that was not possible when his double eagle Liberty design was first used for a coin in the year 1907. The carat rating K of a gold object varies directly as the percentage P of gold in the object. Varies directly as the percentage P of gold in the object. So a 14-karat gold chain is 58.3% gold. What is the percentage of gold in an 18-karat gold ring? So we're going to familiarize ourselves with the problem and translate it. The problem states that we have direct variation between the variables k and p. So it's going to be an equation of the form k equals, we'll call it small k, and p. Where small k is some number greater than 0. As the percentage of gold increases, the carat rating increases. So how do we solve this? The mathematical manipulation has two parts. First, we determine the equation of variation by substituting the known values for k and p in order to find the variation constant k, small k. Second, we compute the percentage of gold in an 18-karat ring. So first of all then, This is the equation for variation of the percentage of gold in gold coins or jewelry. So we know an example here. It gave us some information up top. It said that for a 14 carat, so 14 in place of the capital K, for 14 carats, we still got the small k here, but the value of P, that is the percentage of gold, it said was 58.3%. Well, percent means over 100, right? So we have this equation. We can redo that as 14 equals, well, instead of 58% written this way, we can write it as 0.583 times that lowercase k. Well, if we want to solve that equation for k, we just divide both sides of the equation by 0.583, and that becomes 1, and so k is equal to 14 over 0.583. And if you divide that out, they're telling us that it's approximately 24. It's not exactly 24, but approximately 24. So the equation, the proper equation would be K for carat, K-A-R-A-T, equals 24 P, where P is the percentage of gold. Now that we know that, we can answer the question that asked about what's the percentage of gold in an 18 karat gold ring. So we've got the equation. We know that it's an 18 karat, so 18 equals 24P, and therefore P is equal to 18 over 24, which is the same as 3 over 4. And 3 over 4 is the same as 0.75. If you divide the 4 into 3, you get 0.75. And if you want to represent that as a percentage, that's the same as 75/100ths, or 75%. So that was the answer to that problem. Now, moving to the next page, it says if one variable is equal to the inverse of another variable times a constant, then the variable is said to vary inversely as the other. So if we got an equation y equals a constant divided by another variable, so in other words the inverse of the variable, then this variable varies inversely as the other. So y varies inversely as x. As the value of one of these variables increases, the value of the other will decrease. So if we look on page 556 at number 4, example number 4, find an equation of variation in which y varies inversely as x when they're telling us y is equal to 145 and x is equal to 0.8. So if we just plug those in, we get 145 equals some constant over 0.8. Well, to solve that, if you multiply both sides of the equation by 0.08, you'll end up with k is equal to 145 times 0.8, and if you multiply that out, it turns out that's 116. Okay, so now you know that the equation up here is y equals 116 over x. Now, if, for example, as they asked in this one, find the value of y when x is equal to 25. So if x is equal to 25, we just substitute here, and we'll get 116 over 25. Well, that doesn't divide in evenly, but it does go in 4 0.64 times if you divide it out by longhand. So we have the answer that when x is 25, the y part is 4.68. Let's look at one more, example number 5 on the same page, 556. So, trash removal. The day after the Indianapolis 500 race, local organizations are assigned the task of cleaning up the grandstands. It takes approximately 8 hours for 30 people to move the trash from one grandstand. How long would it take 42 people to do the job? So, familiarize yourself. Think about the situation. What kind of variation would be used? It seems reasonable that the more people there are working on the job, the less time it will take to finish. Thus, inverse variation might apply. So if we let T, capital T, be the time to do the job in hours, and N be the number of people who are doing the job, assuming an inverse variation, we know that the equation is going to look like T equals K divided by N. So as the number of people increases, the time it takes, as this number increases, the time it takes to do the job decreases. So the value of T varies inversely, it's said, compared to the value of N. As one goes up, the other goes down. So we've got the general form of the equation. The mathematical manipulation has two parts. First, we find the equation of variation by substituting the known values for T and N so that we can find a value for K. And second step then is to compute the amount of time it would take if we know that the number of people is N. So take this formula, and we were told that it takes 8 hours, T, 8 hours for 30 people. So if you solve this, that tells you that K is equal to, 8 times 30, or 240. So K is equal to 240. So this equation is really T equals 240 divided by N. Now, they asked us how long would it take if we had 42 people. So instead of, for N, we substitute the value 42. And so now we just have to divide this out. And that's about 5.7 something or other. So in other words, it'll take, if you have this, if it took 8 hours for 30 people to clean up the mess, but if you had 42 people, it would only take 5.7 or less than 6 hours to do it. Okay? Well, I hope that's enough to help you proceed with the homework and quiz that we've got set up for this chapter. Good luck. Thanks. Bye for now.